Okay, we are looking at 11-7 surface area and volume of spheres. So adding on our final formulas that we were talking about, surface areas of cylinders, cones, pyramids, and then also talking about volume of those things. And now we're going to talk about the surface area and volume of a sphere. So a sphere would be like a basketball, for example, which many of you have attempted to achieve greatness in making it, and not many of you succeeded. Actually, only one of you has succeeded. Congratulations, Sierra. So to the rest of you, keep trying. But one of the things we can do is figure out the surface area of this or the volume of this object. And there's two formulas and then a couple other things we're going to talk about. And that is the formula for the surface area of a sphere would be, so we'll call this, they call it T for total surface area, is 4 pi r squared. So remember, surface area, or area, is two things multiplied together. That's your r squared, meaning two variables, r times r, giving you r squared. And then volume for a sphere is going to be 4/3 pi r cubed. So the only thing you need to know is actually your radius. If you know your radius, then you can find the surface area and the volume of the sphere. There's another thing that they talk about and that we'll reference in this, and they have it on page 561, and I'll show it to you here. You can look on page 561. But what that is they talk about a great circle, and rather than me drawing on the board and making it look bad, we're just going to show this. A great circle is when you have a plane that like intersects a sphere at a point, and that's just called tangent, right? And then if it goes through part of the sphere, it like cuts part of the sphere, that forms a circle. But then if it's a great circle, it actually goes right through the center. And that's where we have like something like the hemisphere would be a great circle. It goes right through the center of a sphere. So that's the reference for that. You'll see some of the questions in the book talk about a great circle in that. And so that means that there's like a plane that goes right through the center of the sphere. So we'll do a couple examples here just to find the surface area and the volume of a sphere. So with this, if we were to find the surface area and volume of the sphere, we'll call this number 1. And if you have a, let's go with this. Okay. This would be actually a semicircle or a semi-sphere, if you will. And if we have this, and this is a total of 10 right there, we'll call it centimeters, and we want to find the total surface area, one of the things we have to consider for this is that if it's a half of a sphere, and we're talking about total surface area, you're going to be finding the surface area of the bottom, of half of a sphere, but then also this part that's been cut, like in half, the top's been cut off. Then you also need to find the surface area of the top part as well. So it's actually two parts going on here. Half of the sphere and then a circle, the surface area of the circle. So in this case, for our total surface area, we're going to be finding half of a surface area of a sphere, which is 4 pi r squared, and then adding that to the area of the circle, which is pi r squared for the top. And those are the two things. So then we have a diameter of 10, therefore we could figure out that our radius is going to be 5. And then we just plug in here. We say, okay, 1/2, I'll show our steps here, 5 squared plus pi times, right, 5 squared, should put parentheses around that technically. So then 2 goes into 4 twice, right, and then 5 squared is 25 times 2 is 50, so you get 50 pi plus 25 pi. And if they ever wanted answers in terms of pi, right, that would be 75 pi. And then you could get the decimal value from that by just punching that into your calculator, and you would have 75 times pi gives you a 235.62, and then centimeters, and again it's area, so it's going to be squared. Now the volume is, you don't have to worry about the fact that it's cut in half in the sense of finding the volume of the circle on top, because that would be just finding the area. So volume, though, it's half of a sphere, so we're going to say 1/2 of 4/3 pi r cubed, and r was 5. And so then we do that, we could do 2 into 4 twice, and then this is 125. So volume is equal to 125 over 3 pi centimeters cubed. That would be the exact answer in terms of pi. And then if you wanted to calculate that out, you could go ahead and you would end up with 130.9 centimeters cubed rounded. 130.9 centimeters cubed rounded. Okay. Then, oh, you know what I did? I made an error because I just looked. This is 125. I forgot to multiply that by 2. So that is incorrect. I apologize. It should have been 125 times 2 is 250. So this should have been, retracting that, that should have been 250 over 3. And then 250 over 3, and then times that by pi, and that would give us 261, or just multiplying that answer by 2. So 261.8 centimeters cubed. All right. So that was, made that error for getting that 2 multiplied by that. Okay. What another? Okay. If you have, I'm trying to think if you have a. Okay, find the volume and surface area of this sphere described. So we'll call this number 2. If they give you a sphere, okay, that has a great circle area of 70.58 feet squared, and you need to find the surface area and the volume for that. So again, we want to find total surface area is equal to something and volume is equal to something. Okay, and that's the information they gave us. A sphere that has a great circle area, not our area of 70.58 feet squared. Okay, so in this, we think about, let's go through and look at, again, our total surface area is 4 pi r squared, and then 4/3 pi r cubed. So if I want to find the surface area, or I want to find the volume, the thing that I need is my radius, right? And so if you look up here, they did not give you a radius. They didn't say the radius is 6 or anything like that. So we have to take our information of 70.58 and being the area of the great circle. So in a sphere, right? So if we were to draw a sphere and, you know, call it like this, try to make it look like a sphere like that, okay? So in that, a great circle is going to go right through the middle of our sphere. And then if we know that the great circle goes right through the middle of our sphere, then the radius of the great circle, the radius right there, is going to be the radius of the sphere. So if I can find the radius of the great circle, then I also know the radius of my sphere, and I can plug that in. So what they told you is the area is equal to 70.58, and what I know is the area formula for a circle, right? Or you should, and the area formula for a circle is pi r squared is equal to 70.58. And so if I can then solve for r, then I can find the area of the total surface area and the volume for the sphere, because I can find my radius. So I go divide both sides by pi, and then I'm going to take the square root. We're not worried about the plus minus, we're just worried about the plus because we're not going to find a negative radius. So we'll go 78.58 divided by pi, and that gives us 22.466, and then we take the square root of that, and we get the 4.73. So 4.74 rounded. So when you go to find your total surface area, you can use that. The other thing you can do to avoid any rounding errors is on your calculator, you have that full value. Just plug the whole value, 4.739864108, You can just take that whole value that I have on there, and I will just square, so I'll use that full value. I'll write in here that we're using 4.74. I'm going to take the whole value, and then I'm just going to square that, and then multiply it by pi, and then multiply it by 4, and we end up with 282.32. 282.32. Now, if I used 4.74 rounded instead, times pi times 4, you're going to end up with 282. So with the rounded value, you would end up with 282.34. So this technically is slightly off, but you can see using 4.74 versus your full value, like whatever this gives you, you're pretty close. And so if you use 4.74, you're going to be fine. The less digits you use, though, the farther off you're going to be. So I would definitely use to like the hundreds place there. And then now for volume, you know you just have 4/3 pi r cubed, which again we can use our full value, but I'll just write the rounded value there. But we can take our full value and then cube that, and then multiply it by pi, and then multiply it by 4, and then divide by 3, and we end up with a volume of 446.05. And then this was feet cubed. I didn't put the units there, feet squared like that. Okay, so that would give us our two values right there. Let's see here. Okay, so I think that's enough for now. I'll just give you a couple of little examples there to get you started on looking at some of those problems. And we will be reviewing Monday and then testing on Tuesday.